Good day everyone, I'm Jemarie Maligsa and this is my report for week 6, Internet of Things. And today I will discuss programming IoT devices using the Arduino. What is IoT? So IoT, or the Internet of Things, refers to smart devices connected to the Internet. These devices can send and receive data to perform specific actions automatically. Example, smartwatches, smart home lights, and Wi-Fi controlled air conditioners. We have here the subtopics. We have basics of Arduino programming, reading sensor data, controlling output devices, understanding program logic for IoT. So what does programming IoT mean? Programming IoT means writing code that tells a device what to do based on data from sensors, like when to turn on, how to react to sensor data, or when to send alert. So here is the basic of Arduino programming. So Arduino is a small computer board for IoT projects, uses the C++ programming languages, and controls sensors and devices. So it's like a small chip nga butangan nato siya code para siya ang magsilbing utok sa ato ang kanang mga devices, like automatic device, like just use sa Wi-Fi lang. So Arduino serves as the central controller in IoT devices. So again, mo ni siya ang murag brain. So allowing users to program interactions between components. So making it fundamental for beginners to grasp its functionality and application. So Arduino IDE is where we write and upload program to the Arduino board. So kani siya usa ni siya ka application para dito ta mag-write sa atong i-program sa atong Arduino, sa atong chip. So Arduino is a versatile microcontroller platform that enables users to create various IoT projects, and it simplifies programming with accessible coding language, making it ideal for beginners to control sensors and outputs. Next. So here is the basic Arduino code structure. So Arduino code has two parts, so which is the setup and the loop. So setup, mao ni siya ang nag-run once for initialization, while ang loop continuously repeats action, so making it essential for effective program performance and control. Okay, so here I have a video to show more understanding, so I will play it.
Hello people of the internet, welcome. My name is Adam and this is the Arduino Basics tutorial, where we're going to be talking about how to program an Arduino Uno microcontroller using a little bit of programming. The first thing we have to ask is, what is an Arduino? So it's one of these little things. Now yours might be a different color or it might look a little bit different. That's okay. They come in all shapes and sizes. There's the official Arduinos, and then there's a whole bunch of other ones. They use the same chipset. They're just made by different companies. So what an Arduino allows us to do is write code on a computer. And instead of just seeing what that code does on our computer screen, we can actually run the code through the Arduino. And the Arduino can use wires and things like breadboards and can connect to all kinds of external hardware, sensors, lights, screens, motors, and all of a sudden our code gets to leave the computer screen behind and control things in the real world, which is super cool. Let's have a look at the pins on the board that we need to know how to use and the ones that maybe we'll get to later on. Pin 0 and pin 1 here are a bit special. They're used when we're communicating between two Arduino boards or between two circuit boards. We're not going to see them in these lessons, but feel free to explore a little bit more. I attached a link in the description of this video where you can read a little bit more about some of these pins. The ones that we're going to use a lot of are pin 2 all the way through to pin 13. These pins are going to allow us to send input and output values from our Arduino board or to our Arduino board. You'll notice that some of them have a little squiggly line next to them. This is our pulse width modulation pins, and they just allow us to translate analog data a little bit better as opposed to just on, off, 0, 1 digital data. We'll get to that when we're using it in different lessons, but just be aware of what the difference is. We have several spots where we'll use for grounding out the power on our Arduino. So you'll see a ground port here. You'll see, and 2 more down here at the other side of the board. So we'll use those with our breadboards in particular when we're making sure that we complete our circuit. As far as power goes, the one that we'll be using most often is this 5-volt power, because most of what we run off of the Arduino runs at 5 volts. There is a 3.3 volt power as well, which can be used if you're doing things that require less power, or maybe if you're running off battery and need to conserve battery power. The V in, we're not going to touch in these lessons, but you can explore it a little more. It's when we're using external sources of power for our board. There's a few other things on here I want to talk about. We have our analog inputs. So when things are coming into our Arduino board in an analog form, like potentiometers later on, we'll use our analog ports for that. It's not written on our boards, but A4 and A5 can also be used in a special case as clock and data pins. And we'll see that in a few future lessons related to LCD displays. And there's a couple pins I didn't talk about. So there's this AREF pin, this IO ref, and this reset pin. We're not going to get into those in these lessons, but feel free to click on the link in the description and you can see a little bit more about what they are and how they work. Next up, there's a couple of lights on the board I just want to point out. There's a light that shows that the board has power, or on light. There's a little light here on board that we get to control, and we'll do that in this lesson. And then there's lights that relate to the TX and RX, so when the boards are communicating with each other. On your board, you're also going to see a nice silver box here. There. And that's where we're going to plug our USB cord in, and the USB cord connects to our computer. That does a couple of things. It allows power to run from the computer to the Arduino. It also allows our computer to communicate with our Arduino board, which is important when we want to send the code to the board. On the Arduino, you'll also see a red button. Red button is a reset button. So if you ever want to rerun your code without having to re-upload it from the computer, you can just press the reset button and it'll do just that. Now I get it. That was a lot of information about something you never heard of before you clicked on this video. Don't panic. The reason I'm going through this is just so you have it as a reference. We'll explain each pin that we use in each of the lessons so that it won't be so overwhelming as we're actually going through it. Okay, so we looked at the board and how a board works. We should probably look at the code and how the code works. All right, so now I'm here in my Arduino online interface to write my code. If you haven't gone through the Getting Started guide yet for this video series, now would be the time to pause the video, find that link in the description and go through that. From this point on, I'm going to assume that you either have an account set up online with the web interface for coding an Arduino, or that you have the physical software installed on your computer and you're following along through that. Now I'll be using the web interface for my videos just because I like the way it's laid out a little bit, and for a lot of people who are working on Chromebooks and other things, that's the only option that they have. You'll notice that the differences are very small between the physical software and the online. But if you do have questions, just hit them up in the comments section and me or somebody else should be able to point you in the right direction. First thing we need to do is hop on over and create a new sketch. All right, so this is going to start a new program and we're going to decide whether or not we push it out to our Arduino. A couple of things in this interface. It's going to set me up with a name. It's going to call it sketch and it's going to give the date. And then if you had multiple files you made on the same date, it might give them an A, a B, a C, appended onto the end. Now I don't like that naming, so I'm going to change the name. The little 3-dot menu here allows me to go in and rename my sketch. What do we want to call it? Well, I'm going to call this one Lesson 01. All right, now the reason I put the 0 in there, for those of you who do a lot of folder organizing, is that it helps make sure that things are in numerical order for me, even once I get up into double digits. So you'll see that my name here, Lesson 01, is there. A couple of little things that you may not know if you haven't done any programming before. You'll see this weird slash star and star slash symbol up here. And if I type text in between those, that text is gray, and what I wrote there is this text does not get run by the board. What happens is this is an example of a multi-line comment. So this is a comment, and in all programming languages we have some type of comments. These are places where the people writing the code can add reminders, add additional information for other people who are reading their code, or for themselves for when they have really big programs and they forget what things are supposed to do. But these lines do not get executed by the computer, by the program, the Arduino. So they're just there for us, the programmers who are reading them. A multi-line comment in Arduino starts with a / and a star and ends with a star followed by a /. And anything that happens in between those will be a comment, so it won't affect the way your code runs. So that's multi-line comments. We also have what are called single-line comments. So we don't need a whole block of words to look at. We can just have one line. To do that, we do 2 /. And then anything on this one line is now commented out. This is a single line comment, so it will not get executed by my program, but it's there for me to see. And you'll see that a lot in my code in these videos. I put comments in so that when you pause the video and you're reading my code, you're not just seeing the code, you're also seeing descriptions that I've added to maybe help you understand it a little bit better. But you don't need to type those in your program if you don't want to. So the next 2 things that are going to be staring at you are this void setup with some really strange brackets, and then void loop with a whole bunch of brackets. So we'll both talk about the brackets and what they mean, and what the setup does and what the loop does. So for the rest of this series, you're going to hear me talk about the setup function and the loop function. Okay? And these are blocks of code that are going to get run either once or a whole bunch of times. The code that we have in between the squiggly brackets in the setup function is code that runs one time. So it's going to run the first time our Arduino gets the code pushed to it. Or if we press that reset button we talked about earlier, it will run this code at the very beginning. And then it goes to the loop function. And the code in between the curly brackets here actually continues to loop and runs over and over and over again. Okay, so when we're putting code into that loop function, we should know that, oh, this is the code that's going to run a whole bunch of times. And the stuff we put in the setup function, we only need that once to get everything working the way it should. You'll notice the 2 round parentheses, open and close, right after the word setup. Okay, and a lot of this is syntax. Those of you who've done other programming languages before will be familiar with this. Anytime you're doing functions or methods in different programs, this is a way of defining that is what we're talking about. And then the squiggly brackets are giving us a space, and inside that space is where all the code needs to be. The code will fall in between those curly braces. For our first lesson, we're going to use this environment in our Arduino, and we're going to make a little light turn on and off. And that doesn't sound exciting, but I'm telling you, it's cool to be able to do something on the computer and have something in the real world around you be affected by that. It's not something we do every day. So let's have a look at how we're going to make that happen. What light am I talking about? Maybe we should consider that first. On our Arduino, it's this little light right here. Depending on what model of Arduino, it might be in a slightly different spot, so don't panic if it's not exactly there. So here I am in my code interface, and the very first thing that I'm going to do is above my setup function, but below that multi-line comment. And maybe now is a good time to change that so that it doesn't just have a bunch of gibberish in it. Let's erase that and let's put something that's maybe a little bit more meaningful to what this program is. So this is lesson 01, and we are going to make the onboard LED turn on and off. So now we have something to help us realize what this program actually does. Underneath my comment, and before my setup function, I'm going to do something called creating and initializing a variable. Now this is a core programming concept, is the idea of variable. When we set up a variable, what we're doing is just like in math, when we declare x to be equal to something, we are going to tell the Arduino that something that we've named can have a different value. And we can set what that value is going to be, but the name is always going to be the same. And that way we can always refer to it, even if we don't know what the numerical value of it is. So it's going to look something like this, int space. And this stands for an integer, okay? And those of you who remember this from math, an integer is any non-decimal value, positive or negative. So we're going to set up a variable that's going to store a numerical value that doesn't have decimals. What are we going to call it? It doesn't actually matter what we call it. There are some naming conventions, and as we get into future programs, we'll talk about like no-nos and things that we shouldn't use to name things. So for now, I'm going to go with something pretty straightforward. So I'm going to call it onboard LED, onboard LED. So what I've done here is I've told my program that anywhere from this line on that it sees onboard LED, and this is case sensitive. So the fact that I used capitals at the end of that actually matters. Okay, so be careful. That's a really common mistake. So from this point on, if it sees that onboard LED, it's going to be expecting to find an integer number. Now we can give this a value too, and that's the initialize step. So space equals space. And now I can give it a number to start. Now I'm going to give it the number 13. And I know if you're superstitious, you're not going to like that, but I didn't actually pick that number. Arduino Unos come standard with an onboard LED that is referred to by pin number 13. That's why we picked that number. So what has this one line of code, this tiny little line of code? I could talk forever about this tiny little line of code, because if you don't understand how computers work, this line of code is doing a lot of things. It's creating a value called onboard LED that anywhere in my program I can use that word now, and it knows what I'm talking about. It knows that I'm talking about an integer, so a non-decimal number, and it knows that the value of that number right now is 13. Okay, so now later in my program I don't have to type out 13 a whole bunch of times. And what if that number changed? What if it wasn't 13 anymore and I needed it to be 7? Well, if I had it in there 20 times, I'd have to go change 20 different numbers. But now I'd be able to just have that one variable name and it would automatically adjust for me. It's really, really important that we use variables for this stuff. Awesome. Moving on. Inside of my setup function, when I say that, I mean inside the curly braces after the word setup, I am going to set up the pin mode. Stay with me. Lowercase pin, capital M, lowercase ODE. And I'm going to open a set of regular round parentheses. And in here, I have to say what pin I want to mess with. Well, what pin is it? Well, it's 13, but I don't want to type the 13. I want to use that variable. That's why I went through all that work of making the thing. Onboard LED, comma, and you can put a space or not put a space. I'm a space guy, so I'm going to put it. And then I get to tell it one of two things. Do I want that pin to be an output, or do I want the pin to be an input? An output means my Arduino board is going to send a signal out to something else through that pin. An input means something outside is going to send a signal in. Now I know that this pin is technically on the board, but we're still sending a signal out to that light. So we're going to call it output, and this needs to be in all capital letters. We end our round bracket, and then we put a semicolon. Okay, semicolons are a way of stating the end of a statement, the end of a line of code. So why did I put this in my setup function? Well, because I only need this to happen one time. When the Arduino first fires up, I needed to look at pin 13 and say, okay, from now on, when you see that pin, know that we're going to be sending things out. We're not going to be listening for things to come in. Next thing we need to do is we need to turn our light on. So what I'm going to do is, before we touch the loop function, we're just going to work in setup. So let's turn our light on. So what do I do here? I'm going to do something called a digital write. Digital is lowercase. Write has a capital W. We need to write to our onboard LED. And we want to write a signal that's either 0 or 1, high or low. So high being 1, low being 0. So this is a digital pin. It either has one way or the other way. It doesn't have a whole bunch of mess in the middle. So let's start with high. And you'll notice that output and high, they change color. And that's because Arduino already knows what those variables mean. We didn't have to create them. Arduino already knows about them. So I just have to use them correctly. And then I end with my semicolon. So what should this program do? Well, it should set a variable that sets onboard LED to be the value 13. It should tell the Arduino that that pin is an output pin, and then it should push it with a digital write of a high electrical value, which means it should turn the light on. Right? Now, how do we actually test this? Because we never really talked about that. So in your setup guide that you should have gone through, we would have already talked about how to set it up, but I'll just run through it really quickly for you. On your Arduino, you're going to plug your USB cord into the USB port and plug it into your computer. And I want you to look on my screen right here where it says select board or port. When I plug my Arduino in, that's going to change. So have a look. So my Arduino is plugged in, and you'll now see that it says Arduino Genuino Uno at COM8. So assuming you did good in the getting started guide and you got everything configured properly, you have the right drivers running on your computer, when you plug that Arduino in, that should change for you. So at this point, we are ready to upload our code. Uploading our code says we have this block of code currently that's only on the computer, and I don't want it on the computer anymore. I want it stored on here. So that's what the upload does. It takes the code from the computer and pushes it to the board, and then the board immediately will start running it. So it will run the setup function. So the light on mine is already doing stuff because I had code on here from before. So I'm going to click upload, and you're going to see that it's going to start running through the upload of the code. It says busy, busy. And then you'll see some code down here where it's activating. So let me just pull that up so you can see it. Okay. And then, oh, look at that. If I look at my board, you'll see that I have my light on. The LED is on. Hallelujah. Now let's make it turn off again. What's going to happen if I just put digital right, onboard LED, low? So let's think about something. When we turn a light switch on and then turn the light switch back off, there's actually a delay there. And we might not realize it because we might think, oh, I just flicked it on, flicked it off. Oh, I saw the light turn on, light immediately went off. Cool. Problem is, a computer does things a lot faster than we do. So if I have one line of code that tells it to turn an LED on, and then immediately after it, I have a line of code that tells it to turn it off, I'm never going to see the light turn on because the computer is going to do those two lines of code so fast that I'm never going to see a blink. So what I can do is I can add in a brand new statement that we haven't seen, and it's called a delay. D-E-L-A-Y, all lowercase. And here's our round brackets that we're starting to get comfortable with. And inside of it, I have to put a numeric value in milliseconds. If you don't know, 1 second is 1,000 milliseconds. So we'll delay for 1 second. Before I push this out, let's just think of what it does. Turns my LED on, digital writes a high value. Delays for 1,000 milliseconds, 1 second. And then digital writes a low, so it turns the LED off. Try it. Push this out to your board. See if your light goes on, waits a second, and turns off again. You might have to watch the board when you push the upload. Otherwise, you might miss it because it's only going to be on for 1 second. You can mess with that number too. If you want it on for 10 seconds because you're a little slower picking it up and looking at it, that's fine. You can set that to 10 seconds. You can think about what that number would be if you wanted to do that. So now you've turned it on and you turned it off, and we learned about delays. So we're ready to do kind of the essential part of what this lesson is about, which is having an LED blink on and off. So this is where our loop function is going to come in, because guess how many times this actually ran? 1 time. The LED went on, the LED went off, and that was it. So we want it to actually blink over and over again. So we need our loop function for that. So I'm actually just going to move all this code down. A couple of ways you can do this. If you're comfortable on the keyboard, you're a little keyboard jockey, you can use Control X to cut it and paste it with Control V. You can right click and cut, and you can actually just drag it as well using your mouse. The indentation here, how many tabs, is just for how picky you want to be about it. It's not going to mess with how the program runs. All I'm going to do here is I'm going to add a second delay. And the reason is that now that it's looping, when it finishes turning it off, the next line of code it runs is actually going to be turning it back on again. So same as before, if you have those two lines of code right after each other, you're never going to see what happens. So we need to put a delay in between. So now I should be able to see it on for 1 second, off for 1 second, on for 1 second, off for 1 second. And that's what we want. So let's push this or upload this out to our board and let's have a look. So I'll just point to my light here and you can see it on, off, on, off. And so my LED is turning on for 1 second, off for 1 second. This is exciting. You've just finished your first core lesson, which is learning how the Arduino works, how the software works, how we push code out, and we've started to control something in the real world using a program that we wrote on a computer. It's only going to get better from here. With every lesson, I'm always going to give you an extension, so something a little further that I want you to try. See if you can do that as well. And then in some of the lessons, I'm going to go a step further, and I'm also going to throw a challenge at you. Something that's got a little bit more oomph to it that might take you a little longer to figure out. For lesson 1 extension, I want you to set it up so your LED is on for 1 second, off for half of a second, and then just have it loop that blinking pattern. Now, I know it's the first lesson and maybe, I'm just being a little hard on you, but let's do a challenge anyway. Can you make that little light actually blink in the pattern of SOS? Now, I'm not going to tell you what that pattern is, so Google's for, but maybe you can make a little SOS signal out of your Arduino board. Although I wouldn't recommend using it if you're stranded on a deserted island. I really don't think that LED is bright enough for them to see you. Good luck, and we'll see you back in lesson 2.
Okay, so that's all for the video. So now this time, let's have the reading sensor data. So sensors collect data like lights, temperature, or motion. So Arduino reads this data and reacts. So by the way, sensors play a crucial role in collecting data from the environment. So enabling Arduino to process this information and make informed decision based on the programmed logic and condition. So we have here the common sensors used. So we have the DHT11. So this is used for temperature sensor. So it is basic temperature and humidity sensor used widely. So we have the PIR. So we use this for motion sensor. So it sensors detect the motion, then commonly used in security system like CCTV. Next is LDR. So this is used for light sensor. LDR, by the way, means light dependent resistor. So measures light intensity for various application. And last one is the ultrasonic, which is the distance sensor. So ultrasonic sensors measure distance using sound waves for accurate readings. And each sensor contributes to making informed decisions in IoT system. So here we have another video to show more understanding. So let's play.
Hello everyone, this is Jonathan from JRC. Welcome back to my channel. In this video, we're going to learn how to read from digital and analog sensors. So I used for this example two kinds of sensors. One is a digital sensor and the other one is an analog sensor. The first digital sensor is a rain sensor that is connected to digital pin 7. And the second analog sensor is a grayscale sensor that is connected to analog pin A0. So we start by identifying the global variables that we have before the void setup, so we can use them in all of our program. This is done by writing int, which is an integer. We name the sensor rain sensor equals 7. This shows that the sensor of the rain is connected to the digital pin 7. Then we write int gs sensor equal A0. This shows that the grayscale sensor is connected to the pin analog A0. Then in the void setup, we write serial.begin to start the serial communication that we are going to use later to print the values of the sensor using the serial.print function. And then we write pin mode rain sensor, which is the digital sensor input. This sets the mode of the digital pin 7 to input. So why we used pin mode for the digital sensors and we didn't use it for the analog sensors? As you can see here, we put the pin mode of the digital pin 7 as input because it's connected to a sensor, which shows that it is an input. However, we didn't put the pin mode of the analog sensor because it is an input by default. So we only put pin mode for digital pins and not for analog pins. So we go to void loop now, which is the main code that will run repeatedly. There we identify new integers, which are the values of the sensors. So we name them rain sensor value and grayscale sensor value. The first integer, which is rain sensor value, equal digital read rain sensor, which is the name of the rain sensor that is connected to pin 7. So we read from the rain sensor using the digital read function, and we put the value of the digital read function in a new integer, which is rain sensor value. On the other side, to read from an analog pin, we use analog read, and we put the name of the pin that we just created, which is GS sensor. So GS sensor value equal analog read GS sensor. This function reads the value of the GS sensor, which is connected to pin A0, and then puts it in a value which is called GS sensor value. So now to display the value of the sensors, we write serial.print ln. The ln here is to start a new line after printing each value. As you can see here, we didn't put quotations because we want to print the values inside the rain sensor value and not the word itself. So now this function will read from the rain sensor, put it in rain sensor value, and then print it on the serial monitor. And then after uploading the code to your Arduino board, you can see the value of the rain sensor using the serial monitor function, which is on the upper right corner. If you liked this video and found it informative, don't
Okay, so that's all for the video. So now let's move on to controlling output devices. So output devices are things that perform actions like lights, fans, buzzers, or motors. Each output device contributes to making IoT systems interactive and responsive. So outputs are the actions taken by the device in response to sensor readings, such as activating motors or lighting LEDs. So illustrating the dynamic interplay between inputs and physical responses. Okay. For example, LEDs are used for indication and visual feedback in projects. So motors enables movement and control of mechanical components easily. Buzzers, so produce sounds alerts for various notifications and warnings. And last one is fans, help in regulating temperature and airflow in environment. So here we have another video, and let's to show more understanding. So let's play it.
Today I'm going to show you guys a very simple Arduino project for beginners. We're going to get 3 different LEDs to turn on and turn off in a simple sequence, like you see here. For this, you're going to need an Arduino Uno or similar Arduino board, a breadboard, preferably with a positive and negative rail like this one, 4 breadboard jumper wires, a USB cable for the Uno, 3 LEDs of different colors, here we're using blue, red and green, and 3 220 ohm resistors. Now we're using 220 ohm resistors because they seem to work the best with the LEDs we have, but you could use different resistors depending on your LEDs and your circuit. I've put a link to an inexpensive Arduino kit that contains all these components in the description below. So let's first set up the hardware. The first step is to establish a common ground. To do this, use a jumper wire to connect the ground pin on the Arduino to the negative rail on the breadboard. This allows all the LEDs to use the ground pin on the Arduino. Now we'll insert the resistors into the breadboard. Space the resistors out with one leg connected to the negative rail. Now it's time to insert the LEDs. Before inserting the LEDs, it's important to note that the longer of the 2 leads on most through-hole LEDs is the positive lead. Connecting it the wrong way will cause the circuit to not work. Connect the negative lead of the LED to the horizontal rail on which the resistor is connected and connect the positive lead to an adjacent rail. Repeat this process for all 3 LEDs. Now it's time to complete the circuit. We're going to use output ports 13, 12 and 11 for the output signal. Connect the positive lead of the LED on the right to pin 13, the LED in the center to 12, and the LED on the left to pin 11. The circuit is now complete. Power on the Arduino board by connecting it to your computer using the USB cable. The LEDs on the board turn on and the board powers up. Before we work on our sketch, make sure to download the Arduino IDE for your specific operating system. I'll leave a link to where you can download the software in the description below. Once you've downloaded and installed the Arduino IDE, go ahead and download the sketch to run this program using the link I've put in the description. Open the downloaded file. The program first creates 3 variables, LED1, LED2, and LED3. This allows us to change the output pins without having to modify the entire program. The code in the setup part of the program tells the Arduino that pins 13, 12, and 11 will be outputs. The loop portion of the program is where the actual instructions live. The first 3 digital write functions turn on one LED at a time with a 200 millisecond delay between each of them turning on. The next 3 digital write functions turn off the LEDs with a 300 millisecond delay between each LED. Now you can change the delay between each LED to change the rhythm of the LEDs turning on and off. Now you're ready to upload the program to the board. Click on the Tools tab of the Arduino window. Make sure the Arduino Uno is selected as your board and make sure you select the COM port your board is connected to. Most of the times there will be one COM port available and that will be the one you need to select. Click on the Upload button on the top left hand corner of the screen to upload the program to the Uno. A green progress bar on the lower right hand corner will indicate upload progress, and unless any errors appear in the black message message bar at the bottom of the screen, your board should now be running the program and the LEDs should be turning on and off like you can see here. Hope this tutorial was useful. Please hit like for more Arduino tutorials and
Okay, so now let's move on to understanding program logic. So program logic is how devices make decisions using FL statements. For example, if temperatures below 30 Celsius, so turn on fan. Now ay musa ka siya og 30 Celsius kay mo turn na ang iyahang fan. So automatic mo on. So programming logic is essential for IoT devices because it's enabling them to make decisions based on sensor data. So this ensures automated response to environmental changes, enhancing functionality and user experience. So here we have another video to learn more and understand about the FL statement.
Hi, in this video, we're going to learn how to use if-else statements inside our programs. Let's get started. As a refresher, an if-else statement is a control structure that can be used to direct our programs when it is met with a decision. If-else statements are extremely helpful in physical computing programs because our devices are constantly receiving information about their environment through sensors, and we can use if-else statements to give them directions based on the values they find. If statements work a bit differently depending on the way we define them. If we define multiple if statements one after another, our program will check each one individually and perform actions based on each condition. If we instead use an if-else structure, our program will check the conditions starting from the top, and once it finds one that is true, it will perform those actions and skip the rest of the statements. To write an if-else statement, we use this syntax. Let's explain this a bit. We start our statement with the if keyword. Inside parentheses, we write a condition. Indented below, inside curly braces, we write the commands to run if the above condition is true. Any additional conditions we have can be written inside else if statements. This means that this condition will only be checked if the above condition evaluates to false. We can add as many conditions as we want this way. Our final statement in an if-else statement is an else block, where no condition is named. This is because this block will only run if all the above conditions have evaluated to false. Note that else if and else blocks are optional. Let's take a look at an example. In this example, a variable count is being assigned a value of 7. Inside the if-else statement, there are 3 scenarios that will run different commands based on the value of the count variable. The first condition is checking if the count variable has a value greater than 10. This is not true. So the program continues to the next condition, which is checking if the count variable has a value greater than 5. This is true. So the middle LED will be turned on at half brightness. Since a condition was found true, the last scenario is skipped and the program will continue running whatever commands come after the if-else statement. During your next exploration, you'll be using a new component. A button is a simple switch mechanism that is used to control some aspect of a machine or process. Though there are many types of buttons, they all look generally the same. There are 4 connection points on a button, and they can be added to your circuit in either direction. In this lesson, we learned how to use if and if-else statements inside our programs. Now it's your turn to explore these statements in your own Arduino programs.
Okay, so that's all for the video. So now let's move on to flowchart representation. So flowchart shows the step-by-step process of the programming. So we have here start, read sensor data, check light level motion detected. If yes, then it's okay. But if it's no, turn on the light, then send status to IoT dashboard and end. So a flowchart visually represents the sequence of steps in IoT programming, so showcasing how data flows from sensors through the Arduino to trigger actions based on specific conditions. So next, so we have the uploading the program. So to upload your program, upload your code to the Arduino, so simply connect it to your computer. Click the upload button in the IDE and watch as your program runs on the device. So connect Arduino, click upload, code runs automatically. So next, so testing your device. So first is ensure all connections are secure and properly aligned. Monitor the outputs to verify the device is functioning correctly. Adjust any settings to improve performance and accuracy. Check for any error messages and troubleshoot as needed. And last is document your findings for future reference and improvements. So we have the real world IoT examples. So for example, smart homes like automatic nga kanang aircon, if makadetect siya og kanang init, automatic siya mag-on. Kanang sa suga, if naay mo agi nga tao, automatic siya mo on. So we have also automatic plant watering. So kada iset nimo siya og time, then kung mabot na siya atong time, automatic siya mag-water sa mga plants. So temperature monitoring, so example lani katong kanang aircon. So kung ma-monitor niya nga niinit na ang palibot, so mo automatic siya nga mubuglaw o on. Then smart parking. Okay, so smart parking, so mo ni siya ang solution, help find available spots. So dili na ka ni still mangita asa ka maka-parking kay mo as hatag na siya asa ka dapit mo parking kanang walay mga sakyanan. Okay? And next is this one. So, importance of programming IoT and also challenges in IoT programming. So, the importance, so we have improves automation, save time and energy, builds innovation and creativity. So, automation enhances efficiency and reduce human error in process. And saving time allows focus on more complex tasks and innovation. So, makasave siya sa imuhang time. And the challenge is coding errors, connection problems, and power issues. Kay ang kaning mga automatic kay mag-need pa man sila og internet. Or nay uban dili gamitan lang siya og remote. Okay? So, coding errors can lead to device malfunctions and unexpected behavior. So, kung naay ma-error si mong code, so dili siya mogana. And connection issues may disrupt communication between devices and network. So again, nay uban mga smart gadgets nga need yun siya og Wi-Fi. So balancing benefits and challenges is essential for successful IoT deployment. And that's all for my report about week 6, programming IoT devices using the Arduino. So thank you for listening.